Hi guys, so in this video lecture we'll be talking about alternate axes of symmetry. We'll be seeing some of the examples involving POS, COS, AOS and alternate axes of symmetry. Okay, so let me start off by putting the heading here. So alternate axes of symmetry. Okay, so let us first define it. So if a compound is rotated by a 360 degree by n and we draw the mirror image of it, and if we get the same or indistinguishable compound, then it is known as alternate axis of symmetry. Okay, so let me define it. So if a compound is rotated by 360 divided by n degree and then we draw its mirror image, then if the mirror image is indistinguishable to the original compound, then it is known as alternate axis of symmetry. Okay, just remember one more thing, that the mirror must be placed parallel to the axis of rotation or in the same plane. So mirror be placed perpendicular to the axis of rotation, and the perpendicular should be in the same plane. Okay, so let us take this example with example. So we have something like this. Okay, so here let me put h. So if we actually rotate it along this bond or in the parallel in the same a plane in the plane which is the same plane as the compounds are in, so we will get something like, so if it rotated by 180 degree or s2 180 degree rotation, just put n equal to 2, then we will get something like this. Okay, so now if you place a mirror on it, you will get something like this compound, which was exactly same as the first compound. Okay, hence there is a s2 alternate axis of symmetry here. Okay, let us take some another example. Here we have, this is the first one. Let us say we have this, we have HCl here and HCl here. We rotate across this bond 180 degree, so s2 would come out to be let me put Cl here rather. So s2 would come out to be ClH here and H and Cl here. So if we place a mirror perpendicular to this plane within the same plane as the original compound, so we will get something like HCl and ClH. So I think this compound is similar to this compound, hence there is a s2 alternate axis of symmetry in this compound. Okay, let us take another example. So let us in the another example have a matrix type of question. These type of questions are asked in competitive examinations. So let me make A, B is simple. This group, let me make two more. We have and okay. So here you have W, X, Y, Z. W is POS, COS, X2 and X3. Sorry, C2 and C3. C3 and this is C2. This is C2. Okay. So POS is plane of symmetry, COS is center of symmetry, C2 is axis of symmetry with 180-degree rotation, and C3 is 120-degree of rotation. So does it have POS? Yes, it has POS. This plane can be a POS for this. Does it have center of does it have COS? No. Does it have C2? Yes, if we rotate it across Z plane, we can get C2. So Y is there, so Z is there. No, 120-degree rotation. Anyhow rotate, you won't get the same compound. For this compound, do we have a POS? Yes, we have a POS. Do we have a COS? No. Do we have C2? So yes, we can actually rotate it across this bond. So if we rotate it, you will get the same compound, as H will replace H here, and this H will be replaced by right hand side H. So Y would be there. 120-degree, it won't be there. So W will be there in this compound, and what else? Y will only be there. Why? Because if I rotate it across this bond, it will again form the same compound. Okay. For this compound, we will have plane of symmetry, center of symmetry, axis of symmetry, plane of symmetry, center of symmetry, and C2 and C3 both. Okay. So let us see some more example or some more matrix questions like this. So we have match the matrix type question, where we have this compound, okay. So in this compound, let's suppose W, X, Y, Z and Z dash are W is S2, X is POS, Y being C2, Z being C3, and Z dash being meso compound, whether it's a meso or not. You have to tell from this compound, from this. So what about this one? So this one, does this one have alternate axis of symmetry? So you can actually just convert this compound into 180, just along this plane. Just rotate this compound around along with 180-degree rotation. So you will get some compound like this. So when you place a mirror, so this is the Z plane, right? So this is a Y plane. So the mirror is actually perpendicular to Z plane and within the same plane as the horizontal, within the same plane as the plane of the compound. Okay. So if you place the mirror, these are both mirror images, hence W would be there in this case. Does it have point of symmetry? Just a thing, means if we actually rotate it across 180-degree, it would have rather this compound, this carbon would be here. So what would be the case here is this carbon atom would be rather here, not this one. This one would be here. Okay, and this one would be here. Yes, it's correct. Okay, so is it having excess of plane of symmetry? No, or yes. Okay, so to analyze this compound, you can actually even draw a simpler compound from this. So let's draw a simple compound to analyze the metric points. So now, does it have a plane of symmetry? Yes, it has plane of symmetry. You can pass it from here. Okay, so y would be there. Sorry, x would be there. Does it have c2? C2 is axis of symmetry, but if you rotate it 180 degree, it should be the same. So yes, y is there. Z is c3 axis of symmetry. So does it have c3 axis of symmetry? c3 means rotated with 120 degree, and it should remain the same. So if we rotate it with 120 degree, so how would the compound look like? Let's say I rotate it in the same plane, then this carbon atom would be here at the top place, and this carbon atom would be here. So we would be getting this as the bridge carbons, and we would get something like this. Okay, so this is not same as this. Does it have is it a meso compound? No, because there is no chiral center here. Okay, let's look at another example. Here we have this compound. So will it have plane of symmetry? Yes, it is a sp2 hybridized carbon atom, so they will all lie in the same plane. So it will have plane of symmetry. So will it have is it having c2? So c2 is rotating 180 degree. So if you look like if you just along this plane, if you just rotate it across with 180 degree, so it will be the same compound. Yes, rest it is not having. Okay, let us look at this compound. Okay, let me draw this here, here only. So we have H, Br, CS3, and at the back carbon we have CS3 here, Br here, and H here. So does it have S2, alternate axis of symmetry? Well, I'll leave you for you with this example. You have to rotate it 180 degree, and you have to see whether it actually makes the same compound with mirror image or not. And here we have Br, H, and CS3. Okay, so this compound, you rotate it across 120 degree, 180 degree. So if you rotate it with 180 degree, it will surely not be even the mirror image of each other. Okay, so it will not be the same compound, so it would not be Y or W. We just you can try it and see. For C3, I don't think by rotating the compound with 120 degree it would be the same as this compound. Okay, so does it have POS? Yes, it would have POS. You can have this plane as the POS. So certainly it is having POS. And is it a meso compound? Yes, there are two chiral centers here. And now how can this be a meso compound? There are two chiral centers and there is a plane of symmetry, so this can't be a meso compound. Okay, however it has chiral centers. Okay, so this completes our lecture on alternate axis of symmetry. So from the next lecture we'll be seeing stereochemistry of cumulines. So till then, good luck and goodbye.